Okay, part 5 of my Attack wood gasification boiler with thermal storage install. Thought I'd talk a little bit about how we're getting that hot water to heat the house. And so what I have here is utilizing water to air heat exchangers in the both the plenum and the filter box of the original propane forced air furnace. And up on top of the A coil on the upper plenum, we have a 24 by 24 by 3.5 inch thick heat exchanger, pretty much standard size. And down in the filter box is a 15 by 25. The filter box was originally set up for 4 inch thick, and to get that filter in it, to get that in there, I had to go to a narrower filter. And my thinking behind using the two heat exchangers is I want to be able to utilize storage at lower temps and still heat the house. So I'm trying to stuff as much heat exchanger capacity in here as I can. You'll notice I got a couple isolation valves, so I can restrict flow or cut off flow altogether as it is now to the lower heat exchanger. One concern there is if I don't want to put out too much heat, get too much heat from this lower exchanger, as it could overheat the blower motor and some circuit boards on just to the left of that coil. And one thing about specifications you'll find on these water to air exchangers is they are, for instance, this 24 by 24 I believe was rated at 240,000 BTU. Huge, right? I mean, this is a 100,000 BTU furnace. But keep in mind that that rating is at 180 degree Fahrenheit water feeding the exchanger, a pretty high flow rate. Like I think it might have been up to 20 gallons per minute, and also some pretty incredible airflow through it too, like maybe 3,000 CFM. Now I don't have anywhere near that. You know, I think this furnace might flow about 1,200 CFM. I probably have about, I can achieve up to 7 gallons per minute of flow through that exchanger. And at times I will have 180 degree water, but to utilize storage and extend storage, you want things to work when those temps drop down. And if we can still heat the house with, say, 120 degree water, that's beneficial as we just extend storage, be longer times in between firings. And it's just 1 inch copper connections. The two exchangers are connected in parallel. And if I get back far enough here, we'll see where I connect to the 1 inch, that's PEX, aluminum PEX tubing, and that goes all the way over to the boiler shed. That's what's down in my trench. The lines are down in the trench. I used the foam in trench method. And it seems to be working out so well, though it is a bit risky. If you screw up your method of doing that foam in trench and get water intrusion, you're going to be digging it up and doing it over. So as far as in-ground lines, I would highly recommend spending the money, getting the Thermopex lines or the Reha piping. They're very similar to each other. One thing you got to be concerned with is, especially the Thermopex, their 1 inch rated line is actually less than 1 inch. So when you do your flow calculations, you want to make sure you get enough flow over to your exchangers in the house. And depending on your distance and the flow you want to achieve, you might have to upsize the lines. But that's an important thing to look into, because once those lines are in place and once you've spent money on those lines, it can be anywhere from $12 to $15 a foot. Not to mention renting a Mini X or having somebody put that line in for you. You want to do it right the first time. And I think that's about it for this one.